Good morning to everyone. My name is Shilpa and today my seminar topic is about IPv4 and IPv6 in computer network. Now let us go into the topic and discuss in detail about IPv4 and IPv6. IP address is the system used to identify and locate devices on a computer network, enabling communication between them. It assigns each device a unique numerical label known as an IP address. What is an IP address? IP is an Ethernet protocol. Address is a unique identifier for a device on a network that uses the Ethernet protocol for a communication. It functions like a digital home address, allowing data to be routed correctly between the devices. What is the structure of an IP address? The structure of an IP address is network portion, which identifies the specific network, host portion, which identifies the individual device within that network. Subnet mask helps distinguish the network and host portions. Example, IP 192.168.10 with subnet mask 225.225.225.0. Now we shall discuss the different type of IP addresses. There are two types of IP addresses. One is IPv4 and IPv6. IPv4 is the older format, uses 32-bit addresses, supports 4 billion unique addresses. IPv6 is a newer format which uses 128-bit addresses, supports trillions of addresses to meet growing demand. Now we shall see the classification of IP addresses. The classification of IP address are private IP, public IP, static IP, and dynamic IP. Private IP used within local networks. A public IP used for devices accessible over the internet. Static IP, fixed addresses assigned manually. Dynamic IP, assigned automatically by DHCP services and may change over time. Now we shall see why IP address matters. Why IP address matters is it enables the routing of data across networks, ensures unique identification of devices, facilitates networks management, security, and resources sharing. If you would like to dive deeper into subnetting, IP classes, or how routing tables use IP addresses, I would be happy to walk you through those next. Now we shall discuss in detail about the IPv4. IPv4 Ethernet Protocol version 4 is the fourth version of the Ethernet protocol and most widely used method for identifying devices on a network. It assigns unique 32-bit addresses to devices, enabling communication across intercommunicated networks. The IPv4 operates at the network layer of the OSI model and is responsible for addressing and routing package devices across networks. IPv4 is a core protocol of the Ethernet protocol suite introduced in 1983 by ARPANET. Now we shall see the address format of the IPv4. An IPv4 address is a 32-bit number typically written in dotted decimal notation. Four decimal numbers separated by dots. Each decimal number represents 8 bit, 1 bit ranging from 0 to 225. Key features of IPv4 are addressing, routing, fragmentation, header fields. Addressing provides unique identification for each device on a network. Routing helps data packets find the correct destination. Fragmentation supports breaking large packets into smaller ones for transmission. Header fields includes fields like source addresses, destination addresses, and protocol type. Public versus private IPv4 addresses. Private IPVs used within local networks, whereas IPVs routable on the Ethernet and assigned by ISPs. Some of the limitations of IPv4 are address exhaustion, security, and scalability. Address exhaustion, only 4.3 billion unique addresses are available. Security lacks built-in encryption or authentication. Scalability, not ideal for the growth number of Ethernet connected. Now we have seen about the IPv4 in detail. Now we shall discuss about IPv6 and about their address format in briefly. IPv6 address is 128-bit address which is written in hexadecimal and divided into 8 groups of 4 digits. Leading zeros can be omitted and consecutive zeros can be compressed using. Key features of IPv6 are no need for NAT due to vast address of space, simplify header structure for faster processing, built-in security with mandatory support of IP2, auto-configuration capability. It may be stateful or stateless, multicast and anycast support for efficient data delivery. The advantages of IPv4 are simplicity and formality. IPv4 is well understood and with decades of documentation tools and expertise available. Widespread support. Most devices, software and network support IPv4 by default. Efficient routing. Smaller header size makes packet processing faster. NAT. NAT is nothing but network address translation. NAT compatibility. Network address translation allows multiple devices to share a single public IP, conserving address space. Stable infrastructure. IPv4 forms the backbone of the current Ethernet net with robust routing and DNS systems. Disadvantages of IPv4 are limited address space. It contains limited address space, only 4.3 billion addresses, leading to exhaustion and reliance on NAT. Security limitations. No built-in encryption or authentication realizes on Ethernet protocols like IP2. Manual configuration requires more administrative effort for IP management and subnetting. Fragmentation overhead. Packet fragmentation can reduce performance and increase complexity. Now we have seen about the advantages of disadvantages of IP4 and we shall discuss about the IPv6 in detail. Massive address space. 128-bit addressing supports that 340 undecillion unique IP2, enough for every device on Earth and beyond. No need for NAT. Each device can have a global unique IP, simplifying peer-to-peer communication. Improved security. IP2 is mandatory in IPv6, offering better data integrity and confidentiality. Efficient routing, simplified header structure, improves packet processing and routing speed. Auto configuration supports both stateless and stateful address assignment. Multicast and anycast support enhances data delivery efficiency for streaming and distributed services. Now, disadvantages of IPv6. Some of the disadvantages are limited adoption. Many networks and devices still rely on IPv4, slowing global transition. Compatibility issues. IPv6 is not backward compatibility with an IPv4, requiring dual stack setups or translation machines. Complexity for beginners, hexadecimal notation and longer addresses can be harder to manage and understand. Infrastructure upgrade cost. Transitioning to IPv6 may require hardware, software, and training investment. Security misconcepts. While IP2 is built in, it is not enable configuration. Enable configuration. Now we shall see the summary of the IPv4 and IPv4. Features. This is IPv4 and IPv6. Address length in IPv4 is 32-bit and address length in IPv6 is 128-bit. Address space is 4.3 billion in IPv4 and 340 decillion in IPv6. NAT is required in IPv4 and NAT is not required in IPv4. Security is external. Security is built in IPv6. Routing efficiency is moderate. Routing efficiency is high in IPv6. Configuration is manual or DHCP. Configuration is auto configuration in IPv6. Compatibility is universal and compatibility is limited in IPv6. So these are all the limitations in IPv4 and IPv6. Thank you.